Hello, everybody. Thanks for joining our webinar. Thanks for spending some time today with us. We're excited to get into heat-related illnesses as we go into the summer months. I know last year it was setting some records, heat records last year with what they call the heat bulb. So really important topic, particularly as it relates to PPE, and we are excited to get started. So. Just wanted to introduce Bullard. We are a manufacturer of PPE, both head protection, respiratory protection for industrial and life science users. We have supplied air products that offer some really innovative, cool cooling products like the Vortex tube and some phase change vest products. We're always looking to help educate our users and to provide our users with the expertise and the understanding of the hazards, and what better experts than to partner with an industrial hygienist. So FACS is a nationwide industrial hygiene firm, and they specialize in partnering with production environments and all sorts of different users to help them work safely and create both respiratory programs and just really robust PPE programs. So excited to work with Brad here and help educate us all on heat related illness.
Thank you very much. Well, good morning / afternoon to everybody. My name is Brad Burcz, and I'm a CIH and CSP with Forensic Analytical, or FACS, out of our Detroit office. Been working in the field of environmental health and safety for the last 14 years. And prior to joining FACS, I spent the rest of my career in automotive manufacturing and public utilities. And I appreciate the opportunity to present on this topic today, and thank you all very much for joining. Before we get into the presentation, just some housekeeping items as far as how the webinar platform works with instructions. So if you have any questions for myself at any point during the webinar, go ahead and click on the question icon up here in the GoToWebinar window, and then type your question in the bottom, hit send, and will submit. There will be a few points during the presentation where we have some interactive knowledge check or polling questions for the audience members to engage in. We have about 20 seconds or so to select your response, and then we'll be able to view the answers and proceed. And if you need a certificate for work, please feel free to reach out to us, and we can get you one of these showing that you did attend the webinar with today's date and the topic. All right, so getting into the material itself, what do we want to accomplish today, right? What are our goals here? So I think it's really important, regardless of where anybody's knowledge or skill level is or understanding of the matter, we talk a bit about some of the basics of human physiology as it pertains to thermal stress. And we're really going to get into the different types of heat-related illnesses, or HRIs as we'll be referring them to. We'll identify and talk about some methods for evaluating heat stress. I'd like to provide an understanding of the basic components of a heat illness prevention program, best practices, and core requirements, and as well as identifying some methods to prevent and control heat-related illnesses, or HRIs, especially in industrial environments. So to begin with some sobering statistics, right? What we're looking at here are work-related deaths within the United States due to excessive exposure of environmental heat. And over this 10-year period from 2011 to 2021, on average, it's 50 work-related heat deaths per year, about one a week. It is significant. Putting that in context a little bit more, when we're talking about weather fatalities as a whole, right? And this is not reflective of just work. this is, across the nation here in 2020, it's pretty easy to understand, the human impact of things like floods, fires, hurricanes, tornadoes, especially more recently across the plains. But by far and away, if you look at the 10 and 30-year averages of weather-related fatalities, heat is by far the largest contributor to fatalities, weather-related. And it's also easy to think of heat stress in outdoor environments, right? Construction work activities where you're right there outside, it's hot out, the sun is shining. But when we talk about industrial environments, regardless of where you're at geographically, throughout the country, even when outdoor conditions are cold, especially if you're somewhere near me here in Detroit or in the Midwest, our winters can be pretty intense. Those conditions are not necessarily reflective of what the indoor environments may be. We're going to talk a lot about heat stress factors, and to set the stage, you can really think about this in two ways, right? With heat stress being the effects of your workload or your metabolic rate, your environmental conditions, and then individual factors, right? Within individual factors, we can look at them across a group or between people, like their exposure, duration, how fit they may be, and then also intra-individual differences, which are observations within the same person when looking at them in different times or different situations, right? And when we talk about heat strain, that's the body's response, your physiological response to heat stress, right? And the potential for excessive strain increases as the body struggles to adapt to dissipate excess heat. There's going to be some recurring themes here. If you hear me repeating the same word or words, it's for a reason. With regard to our heat stress factors, again, environmental factors, work or metabolic activity, and then individual worker factors. Right? The environment, we're looking at temperature, ambient temperature conditions, humidity, the degree of air movement. Radiant heat sources are also included in your environmental factors, and your work level or your metabolic rate. And from an individual perspective, things like age, weight, degree of physical fitness, type of clothing that you're wearing plays a huge role in your body's ability to adapt and respond to heat of varying degrees. And as I had mentioned previously, within industrial settings, they're full of heat producing sources. A myriad of processes and individual pieces of equipment can all really help to contribute to excessive heat loads on a worker. And for our first knowledge check, what are the three primary factors that contribute to heat stress? We've got the votes come in here, and the answer is C, right? Metabolic, environmental, and individual worker factors. And we'll get into these again in more detail there as we continue. Talking about the physiology of heat stress, right? How our bodies respond to it. Again, knowing that industrial settings can significantly contribute to heat stress above and beyond their outdoor environmental conditions that may be more obvious or apparent when you think about this. When we get hot, our body's core temperature goes up. Right? And how do we cool ourselves down? Our primary cooling mechanism is sweating. Right? The excess moisture on your skin gets carried away by air currents, and it's cooling through evaporation. Right? As we get hotter, blood gets pumped to the skin surface, and that helps with the transfer of heat to the environment. Maybe what you're wearing, what you're doing, the type of work activity, and that hyper-localized environment. And during really heavy work, high physically demanding work activities, your body can lose to about 2 liters of water every hour. That's a lot. And if you continue to lose fluids and sweat at that rate, it's no surprise, and I'm sure everyone here has experienced it to some degree, but you're going to lose your endurance, right? You're going to feel tired. Could be subjectively, uncomfortable, feel hot and become thirsty. And if you wait until you become thirsty to hydrate, you've waited too long, right? Consistent hydration throughout the day is absolutely critical and is a fundamental aspect of heat illness prevention. So going beyond that 2-3 hours, after 3 hours, dehydration is absolutely going to set in, right? Sweating causes dehydration, which will then reduce the blood volume and reduces skin blood flow, making it harder to shed excess heat, which again is why hydration is such a key component of heat illness prevention, right? Individuals experiencing dehydration are going to get headaches, feel fatigued, generally, losing strength and dexterity, mental acuteness, could suffer reduced alertness, which all increase the risk of injury in industrial settings especially. Next knowledge check. Evaporative cooling occurs through, which results in excess loss of. Are in. So evaporative cooling occurs through sweating, which results in excess loss of water. So it's helpful to view heat in the human body, right, as a scale, right? It's all about balance. And what are we trying to balance? We're trying to balance the amount of heat that your body's producing against the amount of heat your body is able to shed or lose to the environment. Right? And if you wanted to quantify this, right, and model it, as we often do with exposures across the board, whether they're physical, like heat stress, or even chemical, right, we can model them. And they're dependent on a number of factors. Your heat storage rate, S, is what we would like to understand. And there's a number of equations and ways that you can approach this, right? And if you go through the academic literature, you'll find several variations of these equations. And a very simple one to view and that we'll use for purposes today would be the following, right? Where again, our heat storage rate, or S, is going to depend on your metabolism, your metabolic rate, which is directly dependent on how much external work and movement an individual is having to do to accomplish a task. The rate of heat transfer by radiation, right, both from and to the body, depends on a number of things, like the temperature of surrounding surfaces, and your skin temperature, and again, clothing. You can also exchange heat through convection, right, or air movement, and that also depends on the magnitude of the temperature difference between the skin, between the air, how much air movement there is, and again, you guessed it, clothing. In addition to how quickly your rate of heat loss through evaporation, right? You're sweating. That is also dependent on air movement, humidity, right? As humidity increases, right? The air is carrying more water. As humidity continues to go up, it's the surrounding air's ability to absorb or take on that excess water, i.e. your sweat, goes down. Right? And again, it's no surprise that your ability to lose heat through evaporation and sweating depends on your clothing. So there's a number of types of heat-related illnesses, or HRIs, and they're all different ways that our body responds when it can't adequately dissipate heat. There's a number of these syndromes which result from fairly minor, like a heat rash, and we're going to show some examples of them, up to and including heat exhaustion and heat stroke, which is life-threatening. They're all varying forms of an inability of your body to regulate its temperature. There are so many risk factors that come into play when you're talking about the various types of HRIs, right? In industrial settings, factors like ventilation, the type of PPE that you're wearing, inadequate cooling systems, can all contribute to make the situation worse, where you're creating an effect where the hot air is lingering and or temperatures continue to climb. It's not uncommon for some very heavy type of machinery to require its own ventilation systems as well. And ultimately, any machine that's giving off excess heat or steam especially really should have its own local exhaust infrastructure to help ensure that its radiant heat isn't having too much of an impact on those that are working nearby. And of course, there are some solutions like portable fans or AC units that can help to mitigate these concerns, but they're not always practical. Right? It is not uncommon to be in an industrial setting in a factory that's not air conditioned, right? It just doesn't make sense. It's not an effective solution. So what do you do in those scenarios? There's also a number of types of facilities that use real high power density equipment, and that high power density is also going to contribute to the amount of heat that's generated locally indoors. And when you're in these types of environments, right, there are a number of additional impacts that heat stress can have outside of those that you may experience if you're just casually sitting in your backyard or out doing something fun and personal and not work related, right? Your worker performance is definitely going to go down, and it's not uncommon to experience a drop in productivity, your output quality, which are aspects that need to be considered. But most importantly is the risk of accidents and injuries, up to and including fatalities, also goes up significantly as the body continues to struggle to adapt and overcome the heat burden. That there's a number of types of HRIs, right? And we're going to go in order of severity from least severe to more severe. And heat rash is a skin irritation, very common. It's caused through excessive sweating, especially during hot, humid weather. I'm sure that you may have experienced this or seen it on yourself or someone else, where you get these red rashes and maybe look like small pimples or blisters. It's not uncommon for them to show up on your neck or your chest and elbow creases. And if you or someone that you're working with is experiencing heat rash, right, it's always best to, if you can, move into a cooler or less humid environment if it's possible. Keep the area dry. You can use powders to help absorb some of that excess moisture, but don't use ointments or creams, right? That's only going to create further barrier for your body to sweat and effectively cool itself. Going up the list of severity with HRIs, we have heat cramps, right? And that Heat cramps typically affect workers who are sweating a lot during really strenuous activity, because the more you sweat, your body's salt and moisture levels change. And as salt goes down, it can result in painful muscle cramps. And these heat cramps and muscle cramps can be an indicator that heat exhaustion is not the risk of heat exhaustion is going to be going up, and you should be anticipating things only getting worse if you don't take some prompt action, such as drinking fluids, water especially, avoiding salt, and you may have to contact outside medical help, especially if the individual, as far as a worker factor like heart or cardiac health problems, maybe that individual is on a low sodium diet, or if their heat cramps aren't going down or subsiding after an hour of resting, increasing fluid intake, eating something small, you need to get medical help. Heat syncope, which is just a fancy way of saying fainting, right? Or even experiencing an episode of dizziness. It's often occurs if you're standing for too long, or you suddenly stand up after sitting or lying down. And the factors that contribute to heat syncope or fainting include dehydration and not being acclimated to your environment. If you or someone that you're working with does experience heat syncope, it's important to keep them sitting or lying down in a cool place and encourage the slow drinking of water or possibly a sports drink. Right? But we always want to avoid things like pop, soda, high sugar content drinks. Heat exhaustion now is your body's response to losing way too much water and too much salt, and that's usually through excessive sweating. There's a number of symptoms that you may experience, one or more. Typically, it's a combination of several, headache, being extremely thirsty, sweating a lot, feeling having an elevated core temperature, maybe not urinating as much as you normally would based on your level of hydration. And that requires prompt treatment. And that treatment generally includes seeking emergency medical help. And if and when you're in a situation where someone is experiencing heat exhaustion, you need to stay with that person, right? There are way too many reports of someone saying to their coworker, hey, I'm not feeling really well. I'm just too hot. I think I'm going to go in my truck and, we blast the AC for a little bit. I'll be fine. I'll drink some water. And, half hour goes by, coworker goes to check on them, and they have unfortunately passed away because the heat exhaustion is really that serious. So stay with them until help arrives. If they're struggling, you can help take off some unnecessary clothing, especially like their work boots or shoes, or anything on their head or neck. Help them apply like a cold compress, apply water to their head, their face, their neck, and again encouraging them to drink, just sip on water slowly, not trying to drink up an entire bottle of water in a few seconds, but just slow, consistent hydration, again, until that help arrives. Heat exhaustion is when your body is getting very close to experiencing heat stroke, which is the absolute most serious type of HRI. And it is a medical emergency. When experiencing heat stroke, that means that your body just cannot control its ability to regulate its temperature. Your sweating mechanism fails entirely. You just cannot cool down. And when heat stroke occurs, your body temp can get upwards of 105 up to 106 degrees Fahrenheit within 10 or 15 minutes, which can result in permanent disability or death if that individual does not receive emergency medical treatment. Right? Some symptoms to look out for would be altered mental status, confusion, not being as aware of their surroundings as they typically are, slurred speech. They can pass out, which is different from syncope, right? Heat syncope, they're not just fainting briefly, they are losing consciousness and can very easily slip into a coma. Their skin may be hot and dry, again, because their body just cannot sweat any longer. They have lost the ability to produce sweat and cool down. And it is fatal if treatment is delayed. Call 911 if you witness someone experiencing heat stroke. Absolute time is of the essence. Again, stay with them. If you can safely do so, move them somewhere that's colder, even if it's just in a shaded area or a colder part of the facility that you're in, and start trying to cool them as quickly as you possibly can, whether that's with cold water or an ice bath. Even just soaking their clothes with cold water, helping to increase circulation with a fan or whatever you may have on you, to help speed the cooling process, and putting cold compresses on their head, their neck, armpits, and groin area. Now that is not the time to be shy. Seconds count, and any intervention that you can provide until emergency medical treatment arrives is only going to be to that individual's benefit. Next knowledge check. So heat rash, heat syncope, and heat strokes are all types of heat rash, syncope, and stroke are all types of heat-related illnesses. Okay, so we've gone through some basics of how our bodies respond to heat on a physiological level, the types and severity of HRIs. So now it's important to understand, practically speaking, how we in our work environment can begin to evaluate the risk of HRIs. And one of the tools that can be used in the evaluation process is by utilizing the heat index, right, which was developed by the U.S. National Oceanographic and Atmospheric Administration, or NOAA. And it's pretty straightforward in that the heat index combines relative humidity with temperature to give you an apparent temperature. You hear daily on the news, it's 84 degrees, but it feels like 89, right? That's the heat index. It's what it feels like through a combination of temperature and relative humidity. And obviously, the greater the heat index, the greater the likelihood of experiencing an HRI, especially with prolonged exposure and heavy metabolic workloads. Another tool that is very commonly used in evaluating heat stress and risk is something called a wet bulb globe temperature, or also sometimes referred to as wet bulb globe thermometer, or WBGT, WBGT, right? In most situations, environmental heat exposure should be assessed by a WBGT, WBGT, because these readings can be used to determine the degree of heat stress that an individual is experiencing and allow a qualified health and safety professional to determine how to mitigate that heat stress properly and prevent an injury. When air or even vapor impermeable PPE is worn or clothing is worn, the dry bulb temperature or the adjusted wet bulb temperature can be a more appropriate measure than you may get by utilizing another tool such as the heat index, because the WBGT incorporates more environmental factors. In addition to temp and humidity, it's going to look at air movement or wind speed, and then radiant heat loads especially. So when applying WBGT readings, right, the ACGIH has designated a TLV, a threshold limit value, okay, and as well as an action limit for staying safe and working in hot environments for an appropriate amount of time based on the metabolic work rate and load and the effective WBGT temperature. However, there are some very important considerations that you need to understand when applying these types of exposure limits. Right? The TLV was designed for healthy, hydrated, and acclimated workers. Okay, healthy, hydrated, and acclimated. The action limit is set for healthy, hydrated, and unacclimated workers to help them achieve thermal equilibrium. Right? There's a pretty small margin of safety between the two, the TLV and the action level. But the purpose is, again, to maintain thermal equilibrium. Right? The TLV also assumes that someone is going to be completely recovered from previous heat stress exposure. So think about working an 8-hour shift. It assumes that someone has gone home afterwards, has stayed in a cool environment, is being properly hydrated, their body has had that time to recover. Working extended shifts, maybe 12 hours back to back to back, right, is not in alignment with how these tools of evaluation were designed. And we all know that failure to maintain your thermal equilibrium increases the risk of heat stress, and heat stress is going to lead to errors in judgment and risk of injuries. If you notice here on the right, where we're plotting the TLV in the solid line and the action limit in the dotted line, we have the WBGT EFF, or effective WBGT reading, which also includes a clothing adjustment factor. And there are a number of charts and very beneficial, useful information provided by ACGIH to help you apply and interpret these readings based on the environmental conditions specific to you in your indoor environment. But in principle, there's two ways really that you can use the WBGT for outdoors or indoor conditions. Okay, when working indoors or even outdoors with shade or clouds, the WBGT is going to give you a reading based on the natural wet bulb, which is a humidity indicator, and the radiant heat, because it has three sensors: the globe thermometer here in red, the wet bulb in the middle, and the dry bulb. And the dry bulb measures temperature without impact from any other factors. You can think of it as the ambient temperature. Your globe thermometer is going to read radiant heat, whether that's from the sun or process related equipment. And the natural wet bulb is your humidity indicator. And you can take a WBGT reading based on 2 or 3 factors, depending on whether you're working indoors, outdoors, or the degree of shade or cloud protection afforded to you when being outside. Next knowledge check. A WBGT incorporates the environmental factors of are in air temp, humidity, air movement, and radiant heat. Okay, another great tool to help in mitigating and prevention of heat-related illnesses are work rest schedules, right? And there's not a one-size-fits-all approach to this. There's a number of different work rest schedules that are available online. The one featured on this slide here is again provided by ACGIH, and it's based on widget readings, and again incorporates the metabolic or work rate based on light work, moderate work, and heavy work. Adjustments to these times can also and should be made to accommodate like clothing factors. And in essence, all work rest schedules are trying to indicate the same thing. It's the amount of time that should be spent working in given conditions against the amount of time that you should be resting. So if we look here under heavy work with an adjusted temperature of 95 degrees, you have a work rest period of 45 minutes of work followed by 15 minutes of rest. Regardless of the type or individual chart, something that's very important to take away is that these stay times, right, these work periods are given as absolute upper limits, as maximums. They absolutely do not require someone to work for that amount of time. If you have a stay time given as 15 minutes and you experience symptoms of heat stress after 10 minutes, you need to remove yourself from that environment, right? These are upper maximums, okay? And again, they're all dependent largely on your metabolic work rate and temperature. ASH also provides extensive guidance on work rest schedules, and they're based on air temperature with adjustments for direct sunlight and humidity, but they also have some assumptions. They assume workers are well rested, physically fit, continuing to stay fully hydrated, under the age of 40, and that the environment is under 30% humidity and there's some degree of perceptible air movement, right? You can feel the air moving across your body in some regard. But it works the same. You compare your temperature against the type of work intensity, and you get a time to work and a time to rest. We talked about adjustments of the temperature, right? As an example, if conditions are 90 degrees Fahrenheit with partly cloudy skies and 50% humidity, you would make adjustments to this table. You would add 7 degrees for partly cloudy skies and 6 degrees for 50% humidity, and you would arrive at an adjusted temperature of 103 degrees. Okay, so there is some practice involved in properly applying work rest schedules. But again, the takeaway is that they are maximum times, right? Maximum work times, not to be exceeded, and then allowing for appropriate periods of rest. In anticipation of applying work rest schedules, you may need to have extra workers available to accommodate these types of rotation periods, right? Because if you're typically staffed with 1 or 2 people that are responsible for carrying out an activity, and you have high temperatures that require short durations of work followed by long periods of rest, you may need more people to work on the same tasks. So you might be thinking, what are the differences between light work, moderate work, and heavy work, right? And these are general examples and guides. It's typically not a great approach to talk to someone, in the facility, explain, well, you're just doing light work, because it may not feel light to them. And that's a great way to get off to a bad start on the conversation. But generally, light work would be operating highly automated equipment, walking around, doing, inspections, using light hand tools, maybe a wrench, pliers, for short durations. But again, even light work, if wearing, protective clothing or PPE that's going to add to the burden, can both subjectively and physiologically increase heat stress. You can see in the picture, the individual appears to be doing an inspection. We can see based on what they're wearing, their body's ability to shed heat through sweating is significantly reduced. Moderate work activity, shown here in the picture, some jackleg drilling, will be also dependent on the duration that you're using this type of equipment or performing this work. And as a general rule, you look at carrying equipment or supplies between 20 and 40 pounds. But again, the duration with which you have to carry that could very easily put you into a heavy work type of scenario, which an example of would be here, right? Climbing, carrying heavy items over 40 pounds, installing utilities, hand digging, trenching for extended periods would be, heavy work activities. And you would then utilize the appropriate column in your work rest schedule so that the period of work and period of rest is reflective of that work intensity. Now let's check. Work rest schedules are largely dependent on what factors? Right. Work rest schedules are largely dependent on your metabolic work rate and temperature. So continuing on with different ways of evaluating HRI risk, a great free tool is provided by NIOSH or OSHA. It's their heat safety tool. It's a free app that can be downloaded. It's based on the heat index, so temperature and humidity. But it's also important to consider something that isn't addressed in the app would be additional sources of humidity within an indoor environment. So manufacturing processes that give off water, steam leaks, evaporations from wet floors can all increase humidity levels that are indoors. And these readings and measurements you get on the app are based on outdoor conditions. So important to keep that in mind. It also provides information, for training, something that you can, quickly communicate, in the field in real time, and you can program reminders for rest periods and staying hydrated. Okay, so some more specific types of controls, right? Looking at engineering, we always want to follow the hierarchy of controls. It's difficult to eliminate heat, generally speaking. It's just a natural function of the environment, whether you're outside or indoors. But looking at engineering controls, at the top of the hierarchy, we can control for things like convection, air movement, radiation, evaporation. We can help introduce cooler air, whether that's outdoor air that's cooler, or in some scenarios, air conditioning. And we can reduce radiant heat sources through shielding, and just generally increase ventilation. Evaporative cooling is a great engineering control where oftentimes traditional air conditioning is cost prohibitive and frankly ineffective and inefficient because it's so localized. So considering the use of evaporative coolers, which come in a variety of sizes and utilize ambient airflow over water to help cool areas without emitting a spray or a mist. There's a number of types, models that can be used and are widely applicable irrespective of the type of environment that you're in. And the principles all remain the same. You're moving air over a wet material, right? And it helps to reduce heat and can be very portable and specific to an individual workstations or a much larger area. Fans are great sometimes, right? But as an engineering control, in order to be effective, someone's skin has to be naturally sweaty, or clothes have to be damp to help provide something to evaporate, moisture to evaporate and result in cooling. And it's not uncommon in industrial environments to have just a lack of air movement, especially in large indoor spaces, which will lead to stagnant air or stratifications or pockets of hot or cooler air. Again, understanding that air conditioning in and of itself is a point source, right? And it's generally not effective to provide uniform cooling in a large space. And there's also limitations at high temperatures, because as the temps go up, particularly over about 100 degrees, fan effectiveness goes down significantly, and that oftentimes will result in the fan only blowing hot air that can, again, add to an individual's heat burden. Talking about shielding for radiant heat sources, another engineering control where you're trying to lower the process temperature, which usually isn't compatible with the manufacturing process. But these types of shieldings can be highly customizable, and they provide a line of sight control between the heat source and the workers, generally easiest and least expensive. And depending on the placement and individual heat source, you can get significant benefits in reduction and reducing the heat loads of up to around 80%. You can also change how much heat is being emitted by materials through certain types of coatings. Again, those are going to be very specific to process and individual equipment. And just as some examples here on the left, you can see this is part of an offshore gas flare radiant heat shield, where the flares are going to be on top. This shielding is allowing for airflow between the top and bottom of the flare while shielding workers that may be below. And on the right is the more general picture of a heat shield curtain in front of an oven, for example. Administratively, as we work down the hierarchy of controls, we can automate things. Automation can help mitigate heat risks, because high heat areas and machinery won't be as dangerous to people if they don't have to get as close to them or as often. Even moderate automation can help and help limit exposure time. We had talked about work rest regimens and how to apply them. But another key component of heat illness prevention programs would be getting acclimated or acclimatization. Acclimatization, right, is your body getting used to the heat load, and it does not happen quickly. Almost 3 out of 4 heat-related fatalities happen during the first week of working in hot environments. And new workers or workers returning from extended break periods really need to be focused on getting acclimated. And as a general rule of thumb and how to understand how long this takes, there's something called the 20% rule, right? We're on the first day, say on Monday, you're only going to work at full intensity for 20% of the shift. On Tuesday, the second day, you go up to 40%, and by Friday, you're back at, you're at 100% of full intensity work for those given conditions. Can also help make changes, into workload and scheduling during this time in this acclimatization period. You can schedule high physical demand at work activities early in the day when it's less hot or less humid, or encouraging and scheduling more frequent breaks. Because an important consideration of acclimatization is that it takes a while to build, but you lose it pretty quickly. So maybe by Friday, you're fully acclimated, you're off for the weekend. Saturday, Sunday, you're spent largely indoors in a cooler environment. Come back to work on Monday, and you have lost you're not as acclimated as you were on Friday, and the process has to start over again. And it's just very important to understand that it's something that you need to build, keep, and retention is difficult. So Again, prioritizing work schedules, adjusting schedules, and then making these types of accommodations is going to be absolutely critical, administratively. Training, is any good program, right? A good heat stress training program should include some really key components: how to recognize signs and symptoms of HRIs, the importance of staying hydrated, the impact that PPE and clothing can have, reporting of symptoms, first aid and emergency response procedures, right? OSHA makes it pretty simple: water, rest, shade, right? If you look at their training guide, water, rest, shade. Hydration charts are also useful tools, right? Initially developed by the military for urine color. And you may be thinking, well, something as simple as staying hydrated by drinking enough water requires training. And the answer is yes, it absolutely does. These types of charts can be easily posted in restrooms as a general indicator of how hydrated someone is and their need to drink more, making sure they're choosing water, sometimes sport drinks if they're going to be sweating a lot, but more importantly, avoiding things like energy drinks, alcohol after work, or salt tablets. There's a ton of PPE solutions out and available. Things including water or air-cooled garments, ice vests, wetted overgarments, aluminized suits when working around significant sources of radiant heat. But all their proper use and effectiveness requires training and understanding, right? The last thing you want to do is introduce a new hazard. Not all of these products are going to be safe to use in and around energized electrical equipment or performing work that requires FR clothing, for example. Your heat illness prevention program should be planned out in advance, right? Provide basic training to people, have a system in place to monitor temperature and humidity at a minimum, understanding employees are being monitored and monitoring each other for signs and symptoms, providing work breaks, providing water, and making adjustments to controls, when the heat index or your other means of evaluation are indicative of needing to take some sort of action. Broadly speaking, some additional recommendations are to schedule, acclimate, reduce the periods of working in those types of high temperature environments, providing relief in the form of extra staffing or cool down rooms and cool down areas, and providing cool water or liquids to drink. Weather is also important, right? OSHA monitors the heat index. Right? Monitors the heat index, and so should you. They issue heat watches and excessive heat warnings issued by the National Weather Service, typically within about 12 hours of the onset of extremely dangerous heat conditions. The warnings are issued when maximum heat index is going to be about 105 degrees or higher for at least 2 days. OSHA does not have a standard. There's no federal heat standard yet, but in October of 2021, they did issue an advance notice of rulemaking, and some states are not waiting, right? States like California, Minnesota, Oregon, and Washington State have taken initiative to implement their own heat-related standards. Some additional resources OSHA makes publicly available: their National Emphasis Program for heat-related hazards. It's important to note that this National Emphasis Program, NEP, is not a standard, but it will direct enforcement, and what they're looking for is made available and can be easily accessed. And I've got some links at the very last slide for additional resources. Heat.gov is another great resource that's free. We had talked about the OSHA NIOSH heat tool being publicly available and free. Lastly, an important consideration when talking about heat is the combined effects of heat and airborne contaminants, right? When working in warmer conditions, right, they can favor things like allergens or increased prevalence of severity of allergic reactions. High temps can also lead to increased ground level ozone or fine particulate matter being, air pollution, which increase the risk of things like cardiopulmonary dysfunction, reduced lung function, and respiratory illnesses. Generally speaking, the more you breathe, the respiration is increased, the greater your exposure to an individual toxicant becomes, and the more that you sweat and the greater that skin blood flow goes up, the more efficient your body becomes at absorbing contaminants through the skin. Last knowledge check. Examples of engineering administrative controls include ventilation, shielding, work rest schedules, and training. In summary, always remember there's some key elements in prevention of HRIs. Your major heat stress factors being the environment, the work itself, and the worker. Your approach is always going to require a combination of engineering and work practice controls, and your training can be summarized as water, rest, and shade. I'd like to open it up to any questions.
Hey, Brad, we had a few questions come in and we've only got a couple more minutes here, so we'll try and get through one or two here. But the first one is, why aren't cooling PPE featured more prominently in recommendations from OSHA or NIOSH?
A great question. I think there's a high degree of variability in the manufacturer type and style of them. They can and do introduce additional hazards where they may be well intentioned, but they are not always appropriate for the work that is being performed. They also require training on the care and appropriate use of them, and they traditionally don't last super long. Ice vests melt, right? And you're going to need to be prepared to have change-out schedules and management of them.
Great, and we'll just do one more question here. I know there isn't a federal OSHA standard for heat stress, and I work in a state that has yet to publish any formal guidance. Since you mentioned OSHA can cite heat stress under the general duty clause, do we really need to have an official/formal heat stress program?
Good question. The answer would be yeah. Establishing some internal program that's going to outline what your company's policy or procedure is for managing heat is very advisable. Not only helps you demonstrate compliance with regulatory bodies or agencies, but provides a systematic means of mitigating and responding to heat stress risks. And it will help ensure a consistent application of those actions and even retention of associated documents to use.
Great. Well, that is all that we have time for. Thank you, Brad, so much for the presentation. And thank you, Patrick and the Bullard team for your partnership on this. And thank you everyone for joining. Please don't forget to sign up for our 2 upcoming webinars later in the year. We will send those invites out as they come up in Q3 and Q4 of this year. So thank you all. We'll send out a copy of these slides and a copy of the recording as well, so you can share it with your colleagues or anybody else who might be interested. So have a great day. Thank you for joining.
Thank you. Bye-bye.